Welcome to this webinar in WIN-Statik Concrete Beam. This is the first webinar in a series of webinars that I will have for the WIN-Statik software group, and I will have it in English. My name is Fredrik Lagerström, and I work as a product owner of Prestress, and I'm in the technical support of WIN-Statik and FemDesign as well. So today we are going to use the GoToWebinar interface. You may ask questions in the question part of the window that you have on your screens, and that will be answered after the presentation. There is one option to raise a hand during the webinar, but I am not going to monitor that during the presentation. And this presentation will be recorded and it will be made available on the Strusoft YouTube channel later today. A short description of Strusoft and our softwares. We have quite a lot of different applications. The two main ones are FemDesign and Impact, where you in Impact basically draw and monitor the precast elements, and in FemDesign you do structural calculations. And here is a better description of all our software. And yeah, we have the Impact, FemDesign, Diamond and Space Gas, WIN-Statik, Jiggy, Dimension, and my favorite, Prestress. And we have energy software in VIP and BIM Energy. And we also have a document management software called BIM Contact. Strusoft has more than 20,000 users and divided into over 2,000 companies across Europe, but we also are present outside of the European borders. And we have 20 offices and more than 240 employees, and yeah, scattered all over the world. But today we are going to focus on concrete beam and WIN-Statik. So this is the agenda that we will go through. And I will deal with the installation and where to find the applications. We are going to look at the input of data, settings, loads, different serviceability limit state parameters. We're looking at calculations and results. And after this PowerPoint presentation, I will have a live demonstration. And after the live demonstration, I will have questions and answers. So the installation, the application can be downloaded and also updated once it is downloaded using the Strusoft installer, and that is available through this link. It is also possible to get the link here if you have an account on the Strusoft portal that I don't have any link on here right now, but I may show afterwards. And once you have downloaded the Strusoft installer, you go into the correct tab, and in this case it's WIN-Statik, and for concrete beam, you just press install. Of course, you need a license in order to run it. If you don't have a license, then it is basically a trial, or that is in demo mode, so there are a few limitations in that case. But it is also possible to apply for a timed trial version, and I will talk more about that in the last slides. And to start the concrete beam, you either do that by the icon in the Start menu in Windows, or in the WIN-Statik launcher that will be installed as well. And then you have the possibility to start it using the concrete beam icon. And these are the software that I will go through over the course of the next few months. So concrete beam, concrete column, concrete section, punching, frame analysis, and concrete corbel, while the other geotechnical foundation, retaining wall and settlement, and also masonry design and pre-stress will be dealt with after the New Year's break. Using this start menu, you have the possibility to go into the portal where we will look at a few other calculations today. You may contact the support, but also sign up for upcoming webinars. You have the possibility to look at previous webinars and download the Strusoft installer and also get to the WIN-Statik homepage. And now when we are looking at the concrete beam software, we have it downloaded and we start it up. What we can do is that we can input geometry, and we have possibility to input different number of spans and also the end conditions of those spans. We can enter different sections for different parts of the span. And we also have the possibility to enter the support widths and the stiffnesses of the supports. As for material, this is a very common window for all the WIN-Statik software, where it is possible to enter the concrete class and the exposure classes, life classes, consequence classes. It's all a little bit different depending on the national annex and the settings that you have in the different settings or the different national annexes. We can enter the reinforcement details, and here it is where you enter the diameter of the preferred reinforcement bars that you want, and you enter the concrete cover, and it's also possible to set, for instance, the aggregate size, different deviations, but also see what the code says here. So depending on the exposure class and the reinforcement or the secondary bar details that you have here, where we can enter the diameter of the stirrups, then the code will calculate the values that it requires. But it is possible to deviate from this value. But in that case, there will be a warning popping up in the software, basically saying that this is not according to the code. But if you're checking other older structures, the cover may not be according to Eurocode, but according to an old national code instead. We have a few calculation settings, and here it is basically the shear calculation settings for the inclination of the compressive struts. And it's also possible to set the tensile strength and so on. But there are also settings for how the software should do the calculations with iterations and convergence and so on. We have one tab for the reinforcement optimizations, and here it is the method basically to say that you want the reinforcement bars to be shortened layer-wise or individually bar by bar, and also the possibility to round off to the closest 10 millimeter or 100 millimeter. We have the loads, and here you enter the load combinations. And first there is a settings to either check the ultimate limit state or accidental limit state. When entering the loads, you enter it as uniform loads, point loads, triangular loads, and trapezoid loads, and you enter the values and coefficients. And the different values that we have is that you enter the characteristic load value, and then the coefficient multiplier in ultimate load, ultimate limit state. So dead loads might be 1.35, live loads 1.5, and so on, depending on the national annex. We also have coefficients in serviceability limit state for short term, which says total here, and long term. That is the long term serviceability coefficient. And for the long term, we consider crack widths and deflections as well, and it is possible to design according to crack widths and deflections as well. The dead load of the beam is not automatically included, so that needs to be considered as well and taken into account here when adding the loads here. And the loads, they are entered in kilonewton per meter, so it's basically the surface load times the loaded width onto the beam. When we go back and look at the serviceability limit state parameters, it is in the calculation settings, and when we look at the concrete tensile strength, it is in the bottom left corner here. Here it is possible to enter either 2 or 3 different parameters depending on the national annex. The first 2 are the tensile strength for concrete according to Eurocode, where the second one is for more flexural bending. And the third option that we have here is available in the Swedish national annex, where it is a crack width safety factor that you can apply depending on the exposure class. And another serviceability limit state parameters are the creep and shrinkage, and those are entered also in the input of the serviceability state parameters. And here you enter the creep coefficient and shrinkage. And there is also one option here to change how the program will be calculating the deflections and iterations. I would usually just leave this right part and mainly just enter the creep and shrinkage values here. We also have the possibility to design according to crack widths and deflection limitations. By default, it is set to no, but you can enter the values here with regards to what the code says with the crack widths, but also the limitations. I just got one question here actually, and that is quite relevant. Speaking of the creep and shrinkage, there is at the moment no automatic calculation or a tool for calculating this inside the software. But I will show in the presentation another tool that can be used. When we take a look at the calculations, it is divided into the analysis part and the design part. And in the analysis, it is possible to see how the moments and shear curves are looking. And it's also depending on if it's a variable load, the program will load it, the beam differently. So the different moment curves will be overlaid. So parts of this curve will actually be if it's only the variable load acting on the left side or acting on the right side or acting on both or acting on none. And yeah, same goes for the shear curves, and that is why they are looking like they are. When we come to the design, it is possible to design the longitudinal reinforcement, but also the stirrups, of course. And the different results that we get are the number of reinforcement bars, the diameter, the length, and the starting point. So the x1 value here is basically the coordinate from the left-hand side to where this bar should start. As for the stirrups, we are looking at the diameter and the spacing, and that is shown in blue here in this diagram. And it's also possible to look at the results, including the deformations. And that can be shown in the serviceability limit state. And we have the design with regards to serviceability limit state, where we can see the number of reinforcement bars in the different spans. So on the left side, in the middle, and on the right side. And here we can see what the bars needed can be, but it's also possible to change this in order to get another values for the deflections and cracking. So here I have increased the reinforcement and in the left span. So I increased the reinforcement a little bit, and the graphs here will change accordingly as well. So due to cracking, for instance, we are able to adjust the crack widths, and this can be done automatically as well. And here we can see that if it was a non-cracked section, what the deflection would be, but since it is cracked, we now see the larger deflections due to the cracking. One result is also the shortening of the reinforcement. And here we can see how the shortening of each bar is shown. So if I have the 4 bars, we can see 1, 2, and then the 2 blue here are also bars, and it is adjusted according to the moment curve here. If you are running according to the Danish national annex, then it is possible to use a plastic calculation. And for all the other national annexes, this will be grayed out, but for the Danish, it is possible to also design according to plastic design. And that basically means that it is possible to reduce the reinforcement bars. So here in span number 2, I have reduced it from 3 to 1 bar, and that means that there will be a plastic hinge forming, and that the reinforcement or the forces will be redistributed. And this means that the total reinforcement here will be higher than the applied reinforcement. And what this means is that there is one result with regards to the plastic calculation, and that will basically say that there will be forming a plastic hinge over the support, for instance, in this case. And with this, there will be other results depending on the plastic hinges. So a larger positive moment here out in the field, and reinforcement according to that moment distribution in that case. And here we can see the moment that we get in the software and look at the restriction in the plastic hinge calculation. So I will now run a live demonstration of the software. And once I have installed the Serviceability installer, I will go into the WIN-Statik tab, and here I can install the concrete beam. And it's also possible to update it. And here we can see an example of a software that is not installed, for instance. And here the latest release notes will be shown, so it is possible to see what has happened and track different patches and so on. And if there is one patch that is not installed, that will be in not grayed out like this, but it will be actually in black to see that there is an option to update. Once it is installed, any of the WIN-Statik software, there will be the WIN-Statik launcher installed as well. And here I have the software shown. It is possible to switch over to help videos up here, but for the English-speaking audience, the help videos is actually situated on our YouTube channel, and that is where this webinar will end up as well. If I start the concrete beam, I have the option to enter what code, and we only have Eurocode. And we have these 5 different national annexes. It will be updated for the Swedish to ECO as 12 in the soon future now. And that is only with regards to concrete cover for different cement or the amount of Portland cement that you have in the concrete. Everyone has access to all these national annexes, so there is no limitation or extra modules that you need to buy. If you have the software, you have access to everything. I will, for this example, run with the Danish annex. And the reason is that we might look at the plastic calculation. Then I will be presented with the software here. If it by any chance would be in another language, that would be installed in Swedish in that case, then there is one option here to change the language. And currently it is in English, but we have it in Swedish as well. I will of course run it in English today. And when we come here into the input, it is possible to also enter a title, and this is information that will be shown on the printout. Basically the username, company, project, and so on. And it's also possible to see statistics, to see what version it was last saved in and so on. This is more information about the files for the support if there should be an issue with older files. It's possible to see where it was created and so on. If you by accident would enter the wrong code, it is possible to change to any other national annex here as well, and basically convert the file. As for the geometry, I will basically enter the same beam as we saw in the PowerPoint presentation. So I will have 2 spans, and here we can see the different supports that we have. So the left support is hinged and the right support is hinged as well, but it's possible to have it fixed. On the right hand side, we are entering the different span lengths, and that is entered in millimeters. So I will enter 8,000 and 4,500. As for the cross section, we are using a regular type. It's possible to use a T-section, a solid slab, and this is basically that you're looking at a 1 meter wide strip. We have a variable web section and also a variable T section where it is possible to change the different measurements to suit your beam. If we take a look at the rectangular, I will enter a width of this beam of 400. And this is for all spans. So the width will always be constant in this case. But the height should be entered as 600 in span 1. So I will say change. And in span 2, there will be 400 millimeters high. We have the pre-stress software if you want to add different widths for different heights and so on. There is one element type there called custom, and in the pre-stress software it's also possible to calculate non-pre-stressed beams. As for the supports, here we will enter the different widths of the support, but it's also possible to enter the different stiffnesses. So if I have a column above and a column below, then what it's possible to see is a change here in the picture below, basically showing how the conditions of the supports of the beam are looking like. As for support number 2, I will have that a little bit wider, and I will only have a support below, and in that case I leave 0 above, and then we can see that we have a bit wider support here and nothing above. And as for the last one, I have a column stiffness of 200 above and below. Now we are presented with the element, and the values that we saw here, it is the column stiffness in kilonewton meters. As for the material, it is looking a little bit different now in the since we're running the Danish annex instead of the Swedish that I had in the PowerPoint presentation. Here it is possible to change the environmental class, and if you have an inspection level, and I will also change the different reinforcements, and I will also change the strength class of the concrete. If we go into the reinforcement details, we can now see my diameter and the cover that I will be using, shown here in the windows, and also what the code says. And depending on the size of the stirrups, we can see that this will change what the code requirement is for the different bars. It is possible to have this as a code check, basically saying that I will be using 30 and the code says 38. Then I will be reminded every time I do the calculation. Or I can just copy the blue values into my values by pressing the code values. And now the 38 is copied over. So now I'm running according to the code. As for the calculation settings, we can see the shear calculation cotangent theta is 2.5. Here we have the consequence class, and here we have the setting for the serviceability limit state, and as for the Danish national annex, it's only possible to run the 2 different ones. Here we have a slight a small information window, basically showing what the different effective tensile strengths will be in the calculation. As for bar shortening, I will use it layer-wise, and I will use the rounded to the nearest 100 millimeter precision. When we take a look at the loads, I will run the ultimate limit state. And I will enter the uniform loads. And here I enter it as a load number and in what span it should be acting. So load number 1 is acting in span number 1. It is permanent and the characteristic value is 6. I have an ultimate coefficient of 1.35. And I can enter a description to say it's a dead load. As for the next load, it will be acting in span number 2 and it will be 4. And I will be adding that. Next load will be acting in span number 1 again. And this is a variable load of 20. Ultimate coefficient 1.2. 0.7 and 0.5. And this is my live load. And for load number 4, I have it in span number 2, basically the same. So I will add that. It is possible to go in on a specific line and change by just changing a value and press change, or to delete it. And we also have the possibility to enter point loads according to this little picture. Note that it is per span, so it is not from the end of the beam. And we have the triangular load and trapezoidal load. And as I mentioned before, note that the dead load of the beam is not included. So you have to take that into consideration as well. If we go into the serviceability limit state parameters, here it is possible to enter the creep and shrinkage, and this will affect the whole beam. And you either use the Eurocode, or it is possible to use our concrete creep and shrinkage calculator, or if you have an Excel spreadsheet or something like that. You basically just Google creep and shrinkage in concrete and find the Strusoft page close to the Wikipedia page. And when you are in here, it is possible to enter the lifespan of the element, the concrete strength, what kind of cement I have, relative humidity, the cross-section area, and the perimeter of the cross-section that is exposed, and in this case 2 meters. When it is started, and then shrinkage specific inputs. And here I can get the creep and the shrinkage values. And further down below here, it is a calculation according to annex B in Eurocode. That basically shows the calculations, and you can click on the formulas to see all the different parameters that will be used in the calculations. And yeah, same goes for the shrinkage, where we divide it into the drying shrinkage and the autogenous shrinkage. So those are the two according to Eurocode. There is also another called chemical shrinkage, but that is not considered in Eurocode. So we are not considering this here. But I will enter the values for creep 1.82. And 0.42 per mil. As for design options, I would like it to be according to the code. And here I have the possibility to also limit my deflections. So it should be L divided by 240 in this example, for instance. It is also possible to use advanced settings, and that means that you can enter different deflection limitations for different spans. So you basically just go in and select different values here. But I will use one that is for the whole beam. So let's calculate the analysis. And here I now have the moment and shear curves. And that's either the geometry or the curves that can be shown here using the two buttons just below the calculate option here. I will be able to calculate a design, and there were no errors or warnings. And I now have the layout of my element here. Here I can see the bars in the top shown and the bars in the bottom. And also in blue here, I have the stirrups shown here with the spacing needed. I will go into the serviceability limit state. And one thing to note here in this case is that since I have set parameters according to the serviceability parameters, the reinforcement might change according to the ultimate limit design. And here I can now modify the reinforcement if I would like to add more reinforcement, or since this is a Danish annex, I can also reduce the reinforcement. So for the first span here, I can either increase to 4 bars in the middle of the bottom of the first span here. As for the stirrup reinforcement, it cannot be less than the required reinforcement, because then it will not be able to manage the design criteria. But now if I would increase here, then I would get like this. And here we can see that I went from 3 to 4 bars. And I can also run now the plastic design since I changed the amount of reinforcement. And here we can now see that this is the restriction in the calculation. And with regards to this, I can calculate, and yeah, it would not allow me. And that was apparently a software error because it couldn't write the output file. Oh, well. I will look into that, but it seems that there is something wrong with my computer in this case. If we take a look at the values here, we can see the amount needed, and also the x1, as I stated before, is the start point from the left end here. So we can see that this bar starts in this end, and this is so weak that it doesn't really need any bent down reinforcement. The second bar, or the 2 diameter 20, 6.3 meters long, starts at 4 meters into the beam, so basically in the middle here. And yeah, it's one possibility to see, let's say 6. Here we can also see the position as I shown here in the diagrams, a section marking, basically to see how the layout of the reinforcement are located. So yeah, next step is to basically just either go into the printer settings, and this is just the printer. We have the printout options, and here it is possible to go in and select what you want to add, if there's like a detailed information that you want to see. Or we can say just either select all and have extended printings. And then I can have a print preview, and I now have the possibility to see all the in data, exposure classes, materials that I am using, all the details, different spacings, minimum reinforcement spacings, what kind of calculation settings we have, and in this case it's the stringer theory according to the Danish standard, as well as the Eurocode. And this is the final page, and here we have a table of contents shown as well. So here it is possible to see the curtailing, all the results, needed all the diagrams and so on. And yeah, this is the live presentation done. If you would like to learn more, it is possible to try out it using the link shown here, and that is from our strusoft.com homepage. You go into software and WIN-Statik, enter to get the free trial. It is possible to book a demonstration and get a trial license and get a quotation and so on. Otherwise, I will see you in next week, where I will be talking about concrete section